Composition of forces and allied laws of mechanics. After studying this section, you should be able to understand the concept of composition of forces to find resultant, and determine the resultant of a system of two or more forces using either graphical or trigonometric methods. If a particle is under the action of single force, then the net effect of force on the body is easily predictable. Let us take the example of cargo ship which is pulled by single tugboat. Here, if the pull of single tugboat is enough to pull the cargo ship, then it will start moving in the direction of the single force. So, resultant action of the single force is foreseeable. But, what happens if two tugboats pulling the cargo ship with the help of cable at two different angles? In such situation, it is expected that cargo ship must go in desired direction with the help of pull force exerted by two tugboats. Here, a normal judgment says that net resultant action of two force must be in forward direction, which results in forward movement of cargo ship and not in the direction of any one pull force. So, we can say that net resultant action of two forces might go in different direction. To understand this, it necessary to pick up the term composition of forces. The process of combining two or more concurrent forces into a single resultant force is called as composition of forces. The resultant of two or more forces can be calculated using either graphical or trigonometric method. The popular and oldest methods to calculate resultant are: first, the parallelogram law. Second is triangle law, and third is polygon law of forces. Let's see each law one by one. Start with first law, that is the parallelogram law. Consider the two force vectors, drawn with suitable scale in the form of arrows, which shows the direction and magnitude of the two vectors. The parallel lines drawn to the two vectors such that it will form a parallelogram. The diagonal of the parallelogram drawn from the origin of the two vectors represents the resultant of the two forces. This symbolizes the parallelogram law used to calculate resultant of two forces, which states that, if two forces acting simultaneously on a body at a point are represented in magnitude and direction by two adjacent sides of a parallelogram, then their resultant is represented in magnitude and direction by the diagonal of parallelogram, which passes through the point of intersection of the two sides representing the forces. Parallelogram law can be proved by graphical as well as analytical method. Consider the two forces F and G, drawn with suitable scale in the form of arrows, which shows the direction and magnitude of the two vectors. Forces F and G that act at a point P of a body drawn outward from P. These arrows form two sides of parallelogram. The diagonal R of the parallelogram drawn from point P represents the resultant of the two forces F and G. The length of the resultant force R can be directly measured from diagram and represents magnitude, while the direction is from origin of two vectors to the opposite corner of parallelogram. Analytical method. Value of R can be calculated analytically. Let us see. The parallelogram obtained from two forces F and G are represented by PQST. Draw a perpendicular from point S on PQ extended, meeting at point O. As PT and QS are parallel and equal, PT is equal to QS is equal to F, PQ is equal to G, and PS is equal to R. Let angle OQS is equal to theta, and alpha is the angle of R with respect to G. In triangle PSO, PS square is equal to PO square plus OS square, where PO is equal to PQ plus QO. PS square is equal to PQ plus QO whole square plus OS square. PS is nothing but R, PQ is G, QO is F into cos theta, and OS is F into sin theta. So the above equation can be written as R square is equal to G plus F cos theta whole square plus F sin theta square. Simplifying above equation, we get R square is equal to G square plus 2FG cos theta plus F square sin theta square plus F square sin square theta. Again simplifying that equation we get R square is equal to F square plus G square plus 2FG cos theta. Magnitude R is given by R equal to square root of F square plus G square plus 2FG cos theta. In triangle PSO, we can calculate the angle made by resultant with respect to horizontal vector, that is alpha. Referring the trigonometry, we can write tan alpha is equal to OS divided by PO, which is equal to OS divided by PQ plus QO. Tan alpha is equal to F sin theta divided by Q plus F cos theta. Another law which also used to find resultant and is corollary of parallelogram law, known as triangle law of forces, which states that if two forces are represented by their force vector placed tip to tail, their resultant is the vector directed from the tail of first vector to the tip of the second vector. Consider the force system. Here, force F and G acts in a plane. We can find out resultant of these forces by just placing the force vector of F to arrow of force vector G. Draw the vector directed from the tail of G vector to the tip of the F vector. Give name R to new force vector. This R is nothing but the resultant of force F and force G. If the number of forces in the system are more than 2, parallelogram and triangle law are tedious to apply both graphically and analytically. In such situation, when number of forces in the system are more than 2, polygon law can be used to find resultant graphically. The polygon law, which states that if a number of coplanar concurrent forces, acting simultaneously on a body, are represented in magnitude and direction by the sides of a polygon taken in order, then their resultant may be represented in magnitude and direction by the closing side of a polygon, taken in the opposite order. Consider the force system. Here, force F1 to F5 are concurrent, is in same plane and also passing through a common point O. If all the forces are put in the form of polygon, then the closing side of the polygon represented resultant in magnitude, while direction is from the arrowhead of last force to the tail of the first force in polygon.